The first conic section that we'll look at is the circle. And a circle is just the set of all points in a plane that are equidistant from a fixed point. So, for instance, if I had a coordinate plane, and on that coordinate plane was some fixed point, and we generally refer to this as the center of the circle and give it coordinates h and k, then the circle itself is defined by identifying a radius out to another point on the circle. And what we want is that radius to be constant, so the distance from the center to any point on the circle is the same. And as you sweep around, this forms the shape that we know as a circle. And because I'm not terribly great at graphing that, here's an applet to help you visualize. So this applet allows you to put the center wherever you like, and when you place the center, you can then choose whatever radius you would like. What I want you to see is that the radius does in fact stay the same all the way around. So this point P is always a distance that's equal to the radius. Right now the radius is 5.09 units. If I sweep this point around, notice that the distance from the center to point P is always the same, 5.09 units. And the shape that it eventually forms is clearly a circle. And no matter what center point you choose and what radius you choose, that relationship will always hold. So when it comes to developing an equation for a circle, the radius is really this constant distance. So it really kind of makes sense to define a formula for a circle as something to do with the distance formula. So for instance, the radius of the circle is going to be the distance between each point on the circle and the center, and that distance can be calculated using the distance formula as such, and that distance is equal to our radius. So we incorporate the distance formula, and that develops the standard form, or sometimes referred to as the center radius form of a circle. So x and y is a point on the circle. Sorry, this is labeled incorrectly. So h and k is the center. X and y are just some points that exist on the circle, and r is the radius. So for the most part, when it comes to dealing with circles, there's not much we're going to do, but there is one important process that you need to be comfortable with. And that is converting from general form of a circle into standard form. Because as I mentioned, when you're in general form, it's pretty easy to use the coefficients on x squared and y squared to identify the conic as probably a circle. But sometimes there can be situations where you end up with something that's actually just a point, or something that is more in the realm of the complex numbers. So to change into standard form is going to be an essential skill set in order to identify that you really do have the equation of a circle, what the center of that circle is, and what the radius happens to be. So to make that conversion, we have to take advantage of the process of completing the square. So completing the square often gets a bad rap from students, but it's really not all that bad. We do have to do it both in the x coordinates and the y coordinates of this formula, which makes it a little bit trickier, but it's still not that bad. So here's what I recommend. First, separate your x values from your y. And it's okay to just go ahead and leave that constant on the other side of the equation. If it's not on the other side of the equation, go ahead and move it over there, that's fine. Now the next thing that we would do is, I don't know if it's ever really been formally introduced to you as exactly what's happening in the complete the square process, but if you look at it geometrically, when you're completing the square, you have to have the term x squared with a coefficient of 1. Otherwise, you're more like completing a cube. So if there's a coefficient on x squared, you do have to factor that out. So when we factor out the 2 here, that would leave me x squared minus 1/2. And when I factor out this 2 here, that's going to leave me with y squared plus 2y. And one thing that we could do is just simply at this point divide everything through by 2. And that's going to make the process of completing the square a little bit easier. So I think that's probably a good idea. Just go through, divide through by that 2, so we end up having just a constant 2 on this side instead. All right, now when we complete the square, and you know what, I'll just rewrite this just so we aren't getting, so we're looking at the same line as we go through this process. So give me 1 second, equal to 2. Okay. Now here's really the step of completing the square. So we're trying to figure out some value that we can add in the x set of the trinomial there and the y trinomial. So we want to add some number in here that's going to make this entire trinomial a perfect square trinomial. A perfect square trinomial is one that would factor like a plus b quantity squared is a squared plus, 2ab plus b squared. So this would be considered a perfect square trinomial. So we're trying to get it into that form. So to make it that form, here's what we do. So we take this value right here. If I take that, so negative 1/2, divide it by 2, and then square it. So negative 1/2 divided by 2 is going to be 1/4, well, negative 1/4, but then we square it and it becomes positive 1/16. All right, so 1/16. This is the value that I would have to add right here to be in this exact form over here, okay? You can solve for, like if you know what a squared is and you know what 2 times a times b is, then you can solve for what b squared has to be. This is effectively what we're doing. There is a geometric aspect to it, which is nice as well. In the y's, we have 2, that's multiplying the linear variable. We divide it by 2 and square it. This one's a little easier because it's integer, so 2 over 2 is 1, 1 squared is 1. All right, so we can add 1 right here. Now, we simply can't add 1 and the 16 to the left-hand side of the equation without doing the same to the right-hand side. So we're going to have to come over here and add 1/16 and 1 to make that happen. To make everything balance out, that is. Okay, now, we have put effort into taking each of these trinomials and writing them in such a way that they look like this, so that they factor easily like this. And notice it's just the square root of the a squared and the b squared term added together. So just take the square root of the 2 outer terms, which in this case, in the x's, that would be x, and the square root of 1/16 is 1/4. And the sign, you do have to be careful with the sign. If it's minus 1/2 x, we would need to do x minus 1/4, quantity squared. So it factors very easily. And then over here, this would just be y plus 1 quantity squared. Within this group, I would need to do some work with fractions. So 1 is 16 over 16, 2 is 32 over 16. 32 and 16 would be 48. 48 and 1 would give me 49 over 16. All right, so now I'm in center radius form, or standard form, whatever you want to call it. And I can identify the location of the center of the circle, which it didn't ask for, but I'm going to go ahead and do it just because one thing that's a little surprising to students is that the center here is going to be at positive 1/4 and negative 1. And that's just because the minus in front of the values h and k tell you to take the opposite of those values when you read them back. And then the radius is the square root of 49/16. So in this case, that would be 7/4. So that process of converting from general form into standard form is a process that we'll need to use in all of our conics. So you want to make sure you're very comfortable with it in the case of circles, and that will make it easy to do when you get to the slightly more difficult examples of parabolas, ellipses, and hyperbolas. Now, the last thing that we were asked to do is to graph the circles. So with the little bit of space that I have left over here, I'll do my best. Centers at 1/4 and -1. So I'm going to do a fairly large scale. So I'll do like 1, 2, 1, 2, -1, -2, -1, -2. All right, so that way we can get quarter divisions here. So the center is 1/4 on the x and -1 on the y. So my center would be like right here. And the radius being 7/4. So what we do is, or at least what I think is easiest, is just go from the center point, go to the right this distance, so 7/4. So 1/4 plus 7/4 would be 8/4 or 2, so that's nice, just over here to this integer value. Then go up 7/4, so that would be 4/4, which is 1, plus an additional 3/4, so that would go there. And 7/4 to the left, so I'm at 1/4, so subtract that, that's going to put me at -6/4, so -3/2. And go down 7/4, so would actually get me pretty close to -3, and I'm kind of off my chart there, so I'll just draw it in approximately where it should go. And then the circle itself should have the basic shape of a circle as best you can from that point. And there we go.